So this What the Physics video is a review of the adding vectors together. We had already done a basic introduction of what are vectors, how do we add them in parallel, how do we add them if they're perpendicular. This is coming from, let's see, this guy right here from our notes, adding non-perpendicular vectors. So let's go ahead and work this one out. So I walk 4 meters at 30 degrees and 2 meters at 60 degrees. Let's get a basic feel for what that looks like by drawing it out. So if I say here is my origin, 4 meters at 30 degrees. I'm not going to be able to get perfect, lovely angles right here, but that's somewhere around there. 4 meters at 30 degrees. And then 2 meters at 60 degrees. So here's my origin, my newest reference point origin. 60 degrees from there. Actually, let me use a different color. No, I'll still use black. Okay. Something like that. Maybe it should be a little bit shorter because it's supposed to be 2 meters. There. Lovely. And my resultant is going to be from the tail of the first to the tip of the last. And that is not clearly a pretty little right triangle, right? So what can we do about that? We can break it down into the x and y pieces. We can say, hey, this guy and this guy have x pieces. This guy and this guy have y pieces. There we are. If we can break the original triangles down into the x and y pieces, then we are going to do quite nicely. So I have a basic idea of what it is going to look like. Let's go ahead and write out my list of variables. 4 meters at 30 degrees, and then I have 2 meters at 60 degrees. Now, in this case, I only have 2 vectors. If I had more, I could keep listing them one right after the other. I'm doing a vertical list because, as you'll see in just a moment, I'm going to try to get the big X and the big Y right here. So I decided for some reason that my X will be in green and my Y will be in blue. So if you are trying to color code and keep up, that's what today's will be like. You don't have to, but maybe that will help you out. Before we get started, just a reminder of what a triangle is going to be consisting of. Okay, this is the resultant. This is the angle theta, this is the x, and this is the y. If I'm going to deal with getting the y, which trig function is that going to be? If I have my hypotenuse or resultant, and I have my angle theta. So what trig function is that going to be? Sine, right. So sine of theta equals y divided by r. I don't want sine of theta. I want the y component. So what do? What do I move around? I move the r to the other side, specifically by doing what? Multiplying. Right. So r times sine theta equals y. Okay, what about for the x? X and the hypotenuse are going to be what trig function? Cosine. Cosine theta equals x divided by r. I don't want x divided by r, I want just plain x. So that means, okay, multiply the r on both sides. I'm going to have r times the cosine of theta, and that is equal to x. And I actually have those written out on the equation board in the classroom. So Even if you're like, whoa, Farrah, this trig equation stuff is pretty overwhelming for me. Okay, there it is. Anywho, whenever I do this column of x's and y's that I just drew over here, I always write a little reminder to myself above the x and above the y which trig function it is. We just said for the x it's going to be, it's cosine, thank you. So I'm going to write a little cos right up there. For the y it's going to be sine. Okay, excellent. So let me go ahead and do the x for this first one. So I'm going to say 4 cosine 30 in my calculator. Please type that in right now. 4 cos 30, enter. And of course you are in degrees. What does that equal, please? 3.46. 3.46? Okay. And then let's go ahead for the y. That's going to be 4 sine 30. 4 sine 30 is going to be 2. Don't have to worry about rounding. It's exact. And then 2 cosine 60. What is that going to be? Yeah, it should be 1. Cosine is one of those nifty angles, right? Sine of 30 is a half. Cosine of 60 is a half. So, okay, you don't have to know that specific thing to remember it, but some of you do. That's nice. Okay, so anyhow, that's 1. And then 2 sine 60. Enter. What do you get? 1.73. Okay. If there were more vectors listed off, we would keep going. This will go on for as long as you need them. Okay, but then we got to get the big X and the big Y. Yes? So, how do I get my big X and big Y? Well, the nice thing about all these X's is they're all on the X-axis. That means they're all parallel, or possibly anti-parallel. In other words, you would just add and subtract them like they were regular numbers. In this case, I don't have to worry about subtraction because they're all in the same direction. If this had ended up being a -1, in other words, if the vector had been pointing to the left instead of to the right, then I would subtract. But in this case, I'm going to add them up, right? What is 1 plus 3.46? Are you getting out your calculator on this? Okay. Yes? What is it? 4.46. And then 2 plus 1.73. Oh, I definitely need my calculator this time, Farrah. What is it, please? Okay, 3.73. That is my big X and my big Y. So far, so good, I'm hoping. What we've done is broken them down into the little pieces. And then we've added up all those little X and Y's into our big X and our big Y. And what are we going to do now? We're going to combine them together again. To make sure I have a good grasp of what's going on and to help visualize, I'm going to draw out a triangle again. I'm going to say over 4.46 and then up 3.73. And here is my resultant. Okay? It doesn't look perfectly exactly the same as this. It's supposed to, but that's okay. I mean, the resultant is supposed to be about the same size and same angle. Okay, cool. Well, this one right here, oh, sorry, let me swap colors. This X down here is going to be the 4.46, yeah? And this Y over here is going to be the 3.73. So now what am I going to do? Pythagorean theorem. Go, go, go. Tap, tap. Tappity tap. Tappity tap. So it's 4.46 meters, that quantity squared, plus 3.73 meters, which is also squared. Take the square root, and what do I end up with? Say it loud, please. 5.81. 5.81 meters. Lovely and delicious. 5.81. Now, should I have that many significant digits? For the purposes of us understanding this, yeah, have them. I only gave you like one significant digit in each of these in the first place, so. Okay, 5.81. That is this guy right here. That's the magnitude, but I need what? I need the direction as well. I need this angle here, yes? How can I figure out what that guy is? Okay, the arctangent, right. Second tangent y over x. So I would type in, it's my calculator, second tangent, and it would show up like this, tan to the -1, open parenthesis. And then I do y over x, 4.46. Obviously, you're not typing in meters into a calculator, but if you could, it would be okay, because they would cancel out. Divided by, I'm sorry. Yes. I just saw the first number. Okay, excuse me. That should be 3.73, because it's y over x, meters divided by 4.46 meters. And as you can see, the meters end up canceling. Okay, so that's why it just ends up being an angle. What is that lovely angle, by the way?
40 degrees.
Say again? 30 who? 39.9 degrees. Okay, so I'll just put that right up here. At 39.9 degrees. Okay, like I said, in reality, we shouldn't have this many significant digits, but for our purposes right now, making sure we understand. Okay. Good? Questions? Delicious? Right. As we can see on my lovely notes here, that is pretty much what I did right here. Okay? Cool. So I got the same values, yeah? Good. Good. All right, well, let's move on to this. All students take calculus. Now, what the heck does this mean? In our last one, we had this question as one of the quiz questions, and I suggested it was a mnemonic device. I suggested it was a disturbing brainwashing technique to get people taking upper-level math courses, and so on. What does it mean? What does it stand for?
All sine, tangent, cosine.
Okay, yes. So the S and the T and the C are referring to the trig functions. Okay? Pretty much what this breaks down to. In math class, you'll have to go into more detail on this. This is just a simplified version. We use the analytical method. We have to make sure we know which quadrant we're in. That's why I was drawing out the triangle there, just to help us understand, hey, we're in the first quadrant. Easy. If I'm in the first quadrant, I get the angle and I just leave it alone. If I'm in the second or third quadrant, I get the angle, and then I add 180 to it. If I'm in the fourth quadrant, I get the angle, and I add 360 to it. I say, I don't get it, Fair. What are you talking about? Let's see. First of all, let's make sure we understand what the quadrants are. Okay? This is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Do they still use Roman numerals to write these out? Okay, I don't know why they do, but there we go. Okay? This also means all students take calculus. This means that all trig functions are positive in this first quadrant. Only sine is going to be positive in the second quadrant. Only tangent is going to be positive in the third quadrant. And only cosine is going to be positive in the fourth quadrant. Say, Fair, why do I care about that? We're using the arctangent in order to get us the angle. So if I get some vector that ends up in the second quadrant, so instead of positive 4.46 and 3.73, let's say it ended up being negative 4.46 and 3.73. Which quadrant would I end up in there? Well, my x is negative, right? My y is positive, so I'd end up in the second quadrant. Okay? Would that make any difference? Not for the Pythagorean theorem, because that square would get rid of the negative sign. Would that make a difference in terms of the angle? Yes. Go ahead and do this one. Arc, tangent, and then 3.73 divided by negative 4.46. And what do you end up with? The number should look familiar, but not quite. Not quite the exact same. Negative who?
You said negative what? Divided by negative?
Negative 4.46 is the x value, and 3.73 is the y value. Say, second tangent, 3.73 divided by negative 4.46. And what do we end up with?
Negative 39.
Right, negative 39.9. Okay? And that's, of course, degrees. That's for this guy. What would that look like if I were to draw it out? It would look like this. Why is it negative? Because your calculator doesn't really know what to do with the information. I mean, that's a simplified version. It does, but we're pretending it's like this. If I were to draw this vector and I say, oh, the angle going from here to here is positive 39.9 degrees, right? Your calculator is referencing these angles from the x-axis, and it will take the shortest route. So going from here up to here is 39.9 degrees. But it's going in the atypical order. Most of the time, it would be going around like this. You've heard of the term counterclockwise before? Most of y'all don't have analog clocks, but that's counterclockwise, yes? Okay. Most of the time, we're going counterclockwise. Well, this angle was going clockwise. So that's why it's negative. Does that mean anything terrible? Not really. Okay? It just gives you a negative value. So what do you do with that? You add 180 to it. Say, why would I add 180? If I go from here over to here, well, that's 180 and take out the 39.9. Okay, here, let me actually redraw that. If I go all the way over to here, that's 180 in blue. In red, it's 180, and then I take out the 39.9. Okay? So that's why I said add on 180, because when I add on a negative number, it's like I'm subtracting the positive version. Okay? Likewise, if I had something in the third quadrant, in other words, if both of these were negative values, negative 4.46 and negative 3.73, you don't even need to plug that into your calculator. What would happen to those negative signs when you divide them? They would cancel. Your calculator is not going to pay any attention to those negatives. Order of operations say they cancel. Does that mean I'm in the first quadrant? No, I'm actually in the, which quadrant? Third quadrant, which is why I'd have to add 180 as well. Okay? And then if I end up in the fourth quadrant, once again, it's going to take the shortest route, which is going to be in the, quote, negative direction for the angles. That's why I add 360. Okay? If that didn't make a whole lot of sense to you, that's okay. You will learn more about that in your math class eventually. I don't know. Has anyone learned about this before? It's in trig? Is that okay? For right now, all you have to worry about is first quadrant, you leave the angle alone. Second or third quadrant, you add 180. Fourth quadrant, you add 360. Just so we can be consistent. Okay. Julio. Okay. I'm actually